In this video, let's explore shell script control structures, which are fundamental for building logic into Bash scripts. We'll cover if statements, case statements, and loops. These elements enable scripts to make decisions and repeat tasks, automating system administration and other processes. Let's start with if statements. These statements evaluate conditions and execute code based on whether those conditions are true or false. The basic structure involves using the test command or square bracket syntax to define a condition. It is very important to remember that there should be spaces around the brackets. Look at the example code provided. This script checks if a student's score is greater than 70. If it is, it prints you passed. Otherwise, it prints you need to study more. Now let's look at comparison operators used within if statements. These operators help to compare numbers and determine relationships like equality, inequality, or greater than. Here is a quick reference table. EQ checks if two numbers are equal. NE checks if they are not equal. GT checks if the left number is greater than the right number. LT checks if the left number is less than the right number. G checks if the left number is greater than or equal to the right number. Finally, LU checks if the left number is less than or equal to the right number. Use these operators to perform numerical comparisons in your scripts. In this section, let's discuss string and file test operators, which are crucial for handling different data types and file system elements. For strings, Z checks if a string is empty, N checks if a string is not empty, equal sign or double equals equal sign checks if two strings are equal, and is not equal to sign checks if strings are not equal. When it comes to files, E checks if a file exists, F checks if a regular file exists, D checks if a directory exists, R checks if a file is readable, W checks if a file is writable, and X checks if a file is executable. Here we'll learn about nested if statements and logical operators. Nested if statements allow you to embed if statements within other if statements, creating more complex conditions. Logical operators combine multiple conditions. And performs a logical and, or performs a logical or, and exclamation point performs a logical not. The operator performs and operation within test brackets, and O performs or operation within test brackets. Look at the nested if example. This script checks if a person is over 18 and has an ID to determine if they can enter a venue. Next, let's explore case statements, which provide an alternative to multiple if/elif statements. Case statements compare a variable against several patterns, offering better readability for multiple conditions. The key features of case statements include pattern matching, the use of wildcards, and each case ending with a double semicolon. The asterisk matches any remaining patterns, acting as a default case. As you can see in the code block, this script checks the value of the fruit variable and prints a corresponding message. In this slide, we'll talk about the for loops. These loops iterate over a list of items and execute commands for each item. For loops can iterate over explicit lists, command outputs, file contents, and number ranges. As you can see in the code block, the first example iterates over a list of colors and prints each one. The second example uses the output of the less command to process text files. Now let's learn about while and until loops. While loops execute as long as a specified condition is true. Until loops execute until a specified condition becomes true. Here are the script examples. The while loop prints a count from 1 to 5 as long as the count is less than or equal to 5. The until loop does the same, but it continues until the count is greater than 5. Let's explore loop control commands, which modify the flow of loops. Break exits the current loop immediately. Continue skips the rest of the current iteration and jumps to the next iteration. Break followed by a number and exits, and levels of nested loops. Continue followed by a number and continues at the next iteration of the nth and closing loop. As you can see in the code block, This script skips iterations 3 and 4 and exits the loop when I equals 8. Here, we'll look at a practical example and discuss best practices for writing shell scripts. In the code block, there is a script that backs up specified directories to a backup directory, creating a timestamped archive for each. Let's look at the best practices. Always use proper indentation for readability, add comments to explain complex logic, use meaningful variable names, test conditions thoroughly to avoid infinite loops, use exit codes to handle errors, prefer case statements over complex if/elif chains, use functions for reusable code blocks, quote variables to handle spaces and special characters, validate user input before processing, and include error handling for critical operations. By following these practices, you can write more robust, readable, and maintainable shell scripts. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.